Today we're going to talk about section 6.6, trapezoids and kites. The first thing we have is isosceles trapezoids. If a trapezoid is isosceles, then each pair of base angles is congruent. So remember that the word isosceles means that two of the sides are congruent. Okay, in this picture, we have these markings right here showing me that these two sides are congruent. So we have two pairs of base angles that are congruent. We have angle G is congruent to angle H. And with my notation, I can write it this way. Angle G congruent to angle H. And same thing with F and J. So I can say angle F is congruent to angle J. Okay. Next, if a trapezoid has one pair of congruent base angles, then we can assume it is an isosceles trapezoid. So a lot of these definitions kind of go backwards, right? If I tell you that one base angle set is congruent, then the other one is also going to be congruent because these opposite sides are going to be parallel, so you can assume these sides are congruent. Going back to last semester when we talked about triangles, we can also say, oh, congruent angles means I can look opposite to them, and those sides are going to be congruent as well. So that's another way to remember it if you want to write down opposite sides correspond to those congruent angles. A trapezoid is isosceles if and only if its diagonals are congruent. These are the diagonals. This is one of them. We're going to say QS. And that diagonal has to be congruent to the other one, which is TR. Okay, so those things have to be true for an isosceles trapezoid. The diagonals, the lines going across from one angle to the other, those have to be congruent. So let's jump into some examples. Example 1. Each side of the basket shown is an isosceles trapezoid. If angle JML, so J to M to L is 130 degrees, KN is 6.7, so KN 6.7, MN is 3.6, from here to here, 3.6. Find angle MJK, so this one, and find the measure of JL. So a lot going on here. I'm going to start off with JL. I think that one's a little bit easier. So JL is the entire diagonal. If this is an isosceles trapezoid, then I know the diagonals have to be congruent. So in order to find JL over here, I can actually use MK right there to find it out. There's two values there that I already know. I know that this first section is 3.6, and I can actually add the second section, the 6.7, to that to get the full amount. So JL, the diagonal, is 10.3. That's my first answer. Okay, next I want to figure out what angle MJK is. So I'm going to erase this so it's easier to see. I was given this angle is 130. And I'm actually going to modify this picture a little bit. I'm going to extend these lines to help you see something we've done in the past. So these lines are parallel, we know that. And this would be like our transversal, something that we do in the first semester. So this angle right here and this angle right here are consecutive interior angles. And if you remember, consecutive interior angles add up to 180 degrees. So we're going to call this one X, the unknown. X plus the 130 that we have need to be supplementary, so 180. Therefore, the missing angle that we're looking for is 50 degrees. And we always want to go back and name it what it's actually called. So the measure of angle MJK is 50 degrees. And again, this goes back to parallel lines and transversals. And it helps to just extend those lines if you need to. Example number 2. Quadrilateral ABCD has these vertices, and these are graphed for you. Okay, we want to show that ABCD is a trapezoid, and we want to know if it's specifically an isosceles trapezoid. So remember, in order for it to be a trapezoid, the two sides need to be parallel. So this one and this one need to be parallel. So think about how we are going to determine whether they are parallel. We need to look at the slope. Okay, so thinking about the slope, that's how we're going to determine if they're parallel. The second requirement is that these two, the opposite sides, need to be congruent. So how do we determine if something's congruent? You're going to use the distance formula. So it's going to require a little bit of work. Okay? All right, so first, to determine if they're parallel, you can just do rise over run for CD. Okay? If you want to just count, you're going to go from C up 1 and then run 1, 2, 3, 4. So your slope is positive 1/4. And then for the other one, BA, if you count rise over run for that one, you actually go up 1, 2, and then run 1, 2, 3, 4, 5, 6, 7, 8. So rise 2, run 8. If you can simplify, do so. These are both divisible by 2. So that simplifies to 1/4. So check, yes, those are parallel to each other. So this is going to be a trapezoid. But we need to see if the opposite sides are congruent, the sides. So I'm going to take the distance of AD, and I'm going to take the distance of CB. As a reminder, the distance formula is when you take the square root of the difference in your x's being squared, and then the difference of your y's being squared, and add them all up, take the square root of that. Okay? So go ahead and do that. Remember that it's helpful to label your points x1, y1, x2, y2, and so on. Go ahead and pause the video and see if you can solve for the distance of AD and CB. All right, hopefully you had a chance to try this out. When I find the distance for AD, I'm going to put it in this way, but yours could look a little bit different. That's okay. And I end up with the square root of 18. I'm going to do the same thing for CB. Okay, so I have -3 plus 2. There was a double negative there. And I end up with the square root of 17. So they're really close, but unfortunately they are not going to be congruent. Therefore, this is not going to be isosceles because they are not exactly the same. Okay? Awesome. Going on to the next page, we have trapezoid midsegment theorem. The midsegment of a trapezoid is parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. So let's write this out kind of like an equation. So if I asked you to find BE, you would actually take half the sum of the two other ones, AF plus CD. So you would add up the two ends, add them up, divide them by 2, and that's going to give you that middle part, that BE. Okay, so let's put that into practice. Kind of using that equation there that we created. So I know that the middle section, in this case MN, is going to equal half the two ends added up. So the two ends here are KF and JG. So let's fill in what we know, okay? We know MN this time. This is 30. And 1/2 is here. KF is 20, so I can keep that there. And JG is actually labeled as X, so I'm going to replace that with an X. Now, in this case, since we're working backwards, and it kind of just depends on which one you're doing, but in this case, I'm actually going to get rid of the fraction. Thinking about how you get rid of a fraction, 1/2, that's a division problem. So if I multiply this by 2, it'll cancel out. So I'm going to do the same thing on the other side. 2 times 30 is 60. Okay, and on the right side, I just have 20 plus X. Solving for X, I subtract 20 from both sides. 40 is equal to X. So this would be the value of the other side of my trapezoid. Example 4, if you want to pause here and give it a shot, you can. Okay, so we're looking for XY, so I'm going to put an X right there. JK is 18, WZ is 25. Okay. So I know the middle, 18, is equal to 1/2 the two ends added up. My two ends are X and 25. To get rid of the 1/2, I'm going to multiply both sides by 2 so that it cancels. That leaves me with 36 on the left, X plus 25 on the right. I can subtract the 25 over, and that leaves me with 11 as my X value. All right. So that was all trapezoids for the first part of our notes. Now we're going to move on to kites and the properties that make these kites. Okay. So in a kite, the diagonals are going to be perpendicular. And we talked about diagonals being these lines that go across, so from angles opposites to each other. Notice how this is creating a 90-degree angle. That's why they are perpendicular. That's what perpendicular means. Next one, if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent, only one. Okay, in this case, J and L are our only pairs of angles that are congruent. Now, the sides don't necessarily all have to be congruent. In this case, notice how JK and KL are congruent, but then JM is congruent to ML. So think about the sides, the congruent angle being sandwiched between the pairs of congruent sides. So again, this side is congruent to this side, and then this side is congruent to this side. So our congruent angles are sandwiched between that, okay? Hopefully that helps you remember that those are the congruent angles, because sometimes it's going to be a little bit more complicated to kind of see which ones are congruent to each other. So just remember that they are sandwiched between the pairs of congruent sides. So here it is. Here's a good example of that, example 5. If this is a kite, I want you to try to find angle XYZ. So XYZ is here. Now, if you're not paying attention, it's really, really easy to assume that these two are congruent to each other. They are not, okay? And this is why you want to make sure you understand which ones are the congruent ones. Looking at the picture, this side is congruent to this side. I know this because of the markings. And this side is congruent to this side. Again, I know that because of the markings. Therefore, my congruent angles are this one and this one, the sandwiched ones, okay? So if that's 121, this is 121. So a kite has 4 angles. 2 of them are the same. We have a third one, so then how do I find the fourth one? Well, how do I know how much a kite adds up to? A quadrilateral, it doesn't matter which quadrilateral it is, the interior angle sum is going to be 360 degrees. So I have my first angle 73, then I have 121, another 121, and then I have my unknown. All of those together need to add up to 360 because that's what all quadrilaterals add up to, whether it's a kite or a trapezoid or a square, it doesn't matter. When I combine my like terms, all my numbers, I get 315. And to solve for x, I'm just going to subtract that 315 over from both sides. So my missing angle is 45. Remember, you want to go back and answer the actual question. So we want to write it as the measure of angle XYZ is 45 degrees. Okay. All right, I'm going to go ahead and skip number 6 and go ahead and give number 7 a try. Go ahead and pause the video here. See if you can figure it out. Number 7 is very similar to number 5, essentially just different numbers. Again, if it helps, figure out which ones are the pairs of congruent sides. Okay, those are the pairs of congruent sides. The angle between them being sandwiched, those are the congruent angles, so this is 130. I'm looking for angle CDE, so this one. I'm going to call it X for now while I write out my equation. So I know that 64 and 130 and the other 130, the unknown value is 360 because all quadrilaterals add up to 360. I'm going to combine my numbers, combine like terms, and that gives me 324 plus X is 360. Subtract 324 from both sides to solve for that X value. Cancel, X equals, in this case, 36. So again, go back to measure of angle CDE. It's 36 degrees. And that's the end of our notes.